This is a build of the APGS M2 prototype. The nutrient and beneficial microbes are kept in a reservoir that has a pump and pumped up to a fish tank. You can see there's a brown staining of the water. That's the nutrients and beneficial microbes in the water. The hydroponic flow goes from the fish tank into the first tray. The first tray is in the blooming or harvest growth area that has the correct overhead lighting for the wavelengths for the blooming and the harvesting of the plants. It flows out of the first tray into the second grow area, where in the second tray we have a light source that has the correct spectrum for vegetative growth. And then the flow ends up back in the reservoir to be pumped up again. This is an example of a lightweight aluminum-backed LED lighting that has magnetic attachments embedded in the aluminum, and this allows us to put strips of LED lighting where we want on the reflective curtain. For example, the LED strips can be lower beneath the canopy of the plant and irradiate in to provide the correct spectrum of LED generated light to supplement the lighting from the overhead fluorescent light tubes. These are some of the sensors that will be incorporated into the circuit, and this is the circuit as it's building up. The electrical circuit will control the growth conditions, including the water flow, the nutrients, the beneficial microbes, the pH, and the lighting. We're also going to build in a specially designed webcam that detects the growth of the plant by filtering the spectrum so that, for example, only the IR spectrum is recorded or received by the computer, so that we can detect the growth of the plant using a software that's been developed by NASA. This first generation of the M2 needs some refinement. For example, we need to allow for more water flow so that we've got in a higher position of the drain, so that we've got the ability to flood and maintain water at the right level for the plants. This is a electrically controlled flow solenoid or valve, and with it we'll be able to control the ebb and flow type of growth or hydroponic application of the water. This is a pH sensor, and we can continually monitor the pH, and ultimately we'll be able to inject the correct pH up or pH down additive so that the pH of the growth medium is exactly what the plants need. This is a temperature sensor. We'll be detecting the temperature of the water, making sure that the plants are optimally bathed in the correct temperature water. This is part of the pH sensor. This is a flow meter. This is part of the safety mechanism that we'll be incorporating in the system so that we never have an overflow situation and no water ever will spill out of the system. It'll be a completely self-contained closed loop. And then this inexpensive water alarm will be cannibalizing so that we can get a water level